Okay, so welcome everyone to the class. Today's topic that we are going to discuss is de Broglie's hypothesis in dual nature of matter and radiation. So what is de Broglie's hypothesis? First we will look at the statement. Electron shows dual characteristics. Electron shows dual characteristics. If you remember, that is the nature of wave and particle both. That is the nature of wave and particle both. That means electron shows the characteristics of the wave also and characteristics of the particle also. This was de Broglie's hypothesis. You have studied this in class 11th in structure of atom 2. What does it mean? Suppose this is the nucleus of an atom and this is the electron. At first it was believed that electron revolve around the nucleus in a circular orbit. But not in this way, since this shows the characteristics of the wave too. So electron revolves around the orbit in the form of wave. Let us assume this is mean radius r. What should be this one? Wavelength. The distance between the two crests is called wavelength. Then we can say that 2 pi Rn should be equals to n into lambda. This is the general expression for de Broglie's hypothesis. The circumference of the orbit is generally given by n into lambda. See, lambda stands for the particle nature and this is the wave form of electron. So this was de Broglie's hypothesis. Then we will look for photon and electron, the de Broglie wavelength. Let us have a look. We will study this topic in Atoms chapter 2, where we will need to prove the second postulate of Bohr from de Broglie's hypothesis. If you remember the second postulate of the Bohr, an electron can revolve only in that orbit for which its angular momentum is equal to the integral multiple of h by 2 pi. We will study again de Broglie's hypothesis in Atoms chapter, and from de Broglie's hypothesis we will study how to prove second postulate of Bohr. Here is de Broglie's wavelength. Okay. So for photon it is the simple expression. It is given by lambda is equals to h by p, or you can say lambda is equals to h by mv, where v is equals to c, speed of light, because photon travel with the speed of light. But for electron we cannot use this formula. Lambda is equals to h upon mv. See how the formula changes for electron. Because electron gets accelerated in the presence of accelerating potential. So for electron we can write, have a look, lambda is equals to h by p, right? If you remember the relation between momentum and kinetic energy, what was the relation? I am writing it here. P is equals to under root 2 mk. Those who don't know how this relation comes, just have a look. We know that P is equals to m into v. Just squaring on both sides, we will get this. Dividing by 2. These are the simple steps. Half m v square into m. What I have done, say P is equals to m into v. So P square will be equals to m square into v square. Dividing by 2, P square upon 2 will be equals to half. For m square I have written m into m. And v square remains same. So what is half mv square? It is kinetic energy. So P can be written as P square can be written as 2mk. Therefore, P can be written as under root 2mk. This was the basic relation between momentum and kinetic energy. P is equals to under root 2mk. So what we can write here? H upon under root 2mk. If the electron is accelerating through a potential V, then in place of k, we can write E into V. Kinetic energy is equals to E into V. If you remember the formula, say the mass of the electron is constant, charge of an electron is constant, Planck's is constant. Okay. Now we can use this formula. Have a look. Okay, here it will be lambda. Sorry. Yes, lambda is equals to. Now we can use this formula. All the things are constant, so this is the formula for electron. Either if the accelerating potential is given, then you can use this formula, okay? Or if the things are given, if the kinetic energy of electron is given, then you can use this formula. Lambda is equals to h by under root 2mk. So these are the formula. Okay, this expression is in nanometers. This expression is in nanometers, the wavelength. See the two formulas for photon. Lambda will be equals to h by p or simple h by mv, where v should be equals to c, that is speed of light. For electron, the formula changes because electron speed changes in the presence of potential. Either we increase or either we decrease, the speed will change. It does not take place with the photon. So for electron, you can't use the direct formula. You can use this one. If the kinetic energy is given, then lambda is equals to h by under root 2mk. If only the accelerating or deaccelerating potential has been given, then lambda is equals to, this is direct value. Lambda equals to 1.227 upon root v nanometer. This value we have got by putting the value of constants. So have a look at it. Then we will solve numericals in the next session. This was de Broglie's hypothesis and de Broglie's wavelength.